This meeting is being recorded.
In problem 6 from chapter 22, we're asked to look at these pairs of compounds and then determine which of the two is considered a stronger base, and then I'll give an explanation as to why. So let's start with our set here in part A. So what we want to consider every time we determine which is the stronger base is whether or not the lone pair on our nitrogen will be localized or delocalized. So if you recall, that means basically, are there resonance structures? So if we were to kind of move around this lone pair here, we could see that we could generate some resonance structures here. So this would not be the stronger base because it has a delocalized lone pair. But this lone pair here on the nitrogen, we would say is localized, and therefore it's much more available to function as a base. So let's take a look at the compounds in B here and see if we can use the same information to determine. So let's take a look at these specifically. Compound B here, this lone pair would be participating in resonance because we have one pi system here. So we have 2, 4, then we can include these 2 electrons here. And they would contribute to making this compound aromatically stabilized. So because of that, these lone pairs are less readily available, or this lone pair rather, these 2 electrons are less available to function as a base. So this structure over here is going to be our stronger base because that lone pair is not participating in aromatic stabilization in this ring system here. So this lone pair is available. Let's take a look at compound C here again. Let's take a look at these 2 sets of lone pairs here. So this lone pair on this compound over here is localized. So it's not able to contribute to any resonance structures, whereas this lone pair here is delocalized. So again, this is our stronger base. Let's take a look at D here. So this lone pair here versus this lone pair here. We'll start looking at this compound here. This is not the stronger base because this lone pair here, this we could say is highly delocalized because you can imagine, moving around some lone pairs, how many resonance structures we could generate for this compound over here. So this is not our stronger base. We'll look over here and notice that this lone pair would be localized. So again, using that same information, localized versus delocalized, we would consider this compound amongst the set in D to be more basic because that lone pair is localized and more readily available to function as a base.